What is the universe expanding into? We have demonstrated through experiments that the universe is expanding, and that expansion is becoming faster and faster. But what does that mean? Well, the simple answer is the universe is literally expanding into nothing. The universe is by definition everything, so it actually can't expand into anything. All the galaxies in the universe are just moving away from each other. I like to think of it as a chocolate chip cookie being baked. All the chocolate chips are galaxies, and they're moving away from each other as the cookie expands. But for the universe, there's just no oven for the cookie to settle into. It's simply expanding into nothing. Have you ever wondered what would happen if the moon suddenly became a black hole? Let's assume that the mass of this new black hole is the same as our current moon. How big do you think this black hole will be? Well, you're probably wrong, because the black hole would actually be just the size of a single grain of sand. Seriously. Now, despite this, if it were placed in the exact same location as our current moon, not much would change. Sure, we wouldn't see the moon at night, but the orbits would stay the same and our tides, they wouldn't change at all. Everything would be fine until the moon black hole starts eating. If enough mass passed close enough to the black hole, it could create a whirlpool of matter, heating it up and resulting in this crazy scene out of a sci-fi movie. If we know the speed of light, what is the speed of dark? And it is honestly a great question. You see, darkness is really just the absence of light, right? But it's not instantaneous. Like when you turn off a light in your room, it feels like it becomes dark instantly, but it still really takes time for all the light to leave your room. So as it turns out, the speed of dark is really just the speed of light, and it becomes really noticeable across large distances. If Mars suddenly disappeared, we wouldn't notice for around 12 minutes. If the sun randomly stopped shining, we wouldn't know for over 8 minutes. And if our nearest star disappeared, we wouldn't know for more than 4 years. Okay, I have a question for you, and I want you to answer completely honestly. Let's imagine that Elon Musk comes to you tomorrow and he says that he's going to strap you on a rocket and shoot you over to Mars, making you the first human to ever step foot on the red planet. But there is a catch. The mission has just a 5% chance of being a success, and it will take you a total of 10 years to return home if you are successful. So, are you taking the deal? Duets are on. Okay, so we've spoken about the biggest black hole in the universe, but what about the smallest? The craziest thing about black holes is that, in theory, they could be as small as a single atom. And while these atom-sized black holes look tiny and cute, don't underestimate them. They still have the mass of an entire mountain squeezed down into that tiny amount of space. Literally everything can become a black hole if it's squeezed down small enough. For example, if you squeeze the Earth down to the size of a sugar cube, it would form a black hole. We've all been told that Jupiter protects us from asteroid collisions, but I've got some bad news. Jupiter is not our friend. A new paper was published where they ran simulations of the solar system and varied the mass of Jupiter to see how this would affect collisions here on Earth. Surprisingly, they found that a solar system without Jupiter resulted in 3.5 times fewer asteroid collisions here on Earth. So no, Jupiter isn't our protector after all. Mercury's core is shrinking, and I know that sounds weird, but let me explain. Mercury's iron core is slowly cooling down, causing it to shrivel up, kind of like how a grape shrivels up into a raisin. And I know this sounds kind of scary, like what if this happens to Earth? Are we gonna die? Relax. The Earth isn't shrinking. We are safe. And even if you did live on Mercury, you would barely even notice. Mercury shrinks the equivalent width of 2 red blood cells each year, which is really nothing. I mean, the moon moves like 2 inches away from us each year, and even that's barely noticeable. Have you ever wondered what a sunset would look like on Mars? Well, thankfully, we have rovers there that have taken pictures for us. The sunsets on Mars are this beautiful blue color. The sunset looks blue because the fine dust allows the blue light to penetrate the atmosphere more efficiently than other colors. And you can probably notice that the sun looks pretty small. That's just because Mars is further away from the sun than the Earth, so the sun only appears about 2/3 the size. What would happen if the sun exploded? Right now, it takes light 8 minutes and 20 seconds to reach us from the sun, so we wouldn't notice any change initially. We would see the explosion happening and watch the shockwave headed towards us for at least 12 hours. However, chances are we wouldn't be alive when the explosion arrives, as temperatures on Earth will quickly rise, cooking everything on the planet. The closer day side would likely go first, and the night side would probably suffer for longer. But don't freak out. This isn't possible. However, in 5 billion years, the sun actually will expand and consume the Earth. But we won't be around then, so it's okay. In 2015, astronomers observed a perplexing phenomenon as a particular star appeared to dim in a pattern previously unseen. Some astronomers even speculated that this unusual dimming might be attributed to an alien megastructure enveloping the star. This star, affectionately dubbed Tabby's star, baffled astronomers for years with its erratic fluctuations in brightness. The challenge lies in the multitude of potential explanations for this phenomenon. It could be caused by colossal planets obstructing the star's light or vast rings of interstellar dust. However, personally, I find the idea of a Dyson sphere captivating, an extraterrestrial megastructure designed to harness energy from a star. What's your take on it? Did you realize that during the Apollo missions to the moon, the astronauts left behind a significant amount of items, including human waste? Across 6 moon landings, it seems that nature called quite frequently, resulting in the abandonment of 96 bags of human waste on the lunar surface. What's particularly intriguing is that some scientists are advocating for a return mission to retrieve this waste. Their interest lies in examining whether the microbes present in the feces have managed to survive in the harsh lunar environment. The rationale behind this is that if these microbes can endure on the moon, it raises the possibility of microbial survival on asteroids. Considering that the origins of life on Earth remain a mystery, some theories suggest that life may have been transported here via a rogue asteroid. Exploring the survival of microbes in space could offer insights into this hypothesis and the potential for life beyond Earth. Let me introduce you to the planet often dubbed Earth 2.0, Kepler 452b. This celestial body bears such striking similarities to Earth that it's almost eerie. It revolves around a star much like our Sun and completes a full orbit in 384 days, just 5% longer than our year here on Earth. Interestingly, this orbit would result in precisely 32-day months, a tidbit that seems oddly satisfying. However, Kepler 452b is classified as a super-Earth, boasting a size 50% larger than our home planet and a mass 5 times greater. Consequently, gravity on its surface would feel twice as strong, effectively doubling everyone's weight. Given these considerations, would you prefer to reside on Earth or its intriguing counterpart, Earth 2.0? The water you drink might actually be older than the Earth or the Sun. Seriously, astronomers believe as much as half of the water on Earth actually traveled here as little bits of ice from a cosmic cloud. But it goes deeper than that. In every glass of water you drink, some of the hydrogen atoms are a special isotope of hydrogen called deuterium. We think pretty much all of the deuterium in the universe was formed just 1,000 seconds after the Big Bang. So with every sip of water you take, remember, you are literally drinking atoms formed in the beginning of the Big Bang 13.8 billion years ago. Astronomers believe the massive star Betelgeuse is going to go supernova in your lifetime. And when it does, it will be as bright as the moon. You will even be able to see it during the day. Betelgeuse is 650 light-years away from Earth, far enough to ensure that we won't be in any danger when it does explode. We have seen events like this before. 1,000 years ago, Chinese astronomers noticed a guest star appear out of nowhere, and Native American petroglyphs indicate that they saw it too. We now know that they were watching a supernova taking place, and in fact, it was the formation of the Crab Nebula that they got to see. Days on Earth are literally getting longer each year. The moon moves 1.5 inches further away from us, which is a lot if you ask me. As a result, the Earth rotates slower every single year, making our days longer. 1.4 billion years ago, a day on Earth was just 18 hours long. And in 1 billion years, each day will be 28 hours long, meaning you can get a full night's sleep and still have a full 20 hours for activities.